Hey guys, this is Carl with another video, this time on how exactly these multicopters work. So, as you guys may already know, there are many kinds, but the kind I'm going to focus on today is a quadcopter. Now, it has 4 blades and 4 motors that work independently of each other. They're not chained to go at the same speed or in the same direction. So it's similar to a helicopter in that each motor spins and produces lift. However, the order of the motors and the kind of blades they have actually matters on a multicopter. So 2 blades counter-rotate in order to counteract the rotational forces they impart on the entire quad. But the other 2 props counter-rotate in the opposite direction to not only counteract each other, but to counteract the other 2. So that when all 4 are spinning at the same time, there should be a net upward force and no other external force. So each motor is what's called a brushless motor, which basically means that the spinning part holds magnets that are pushed around by coils of wire inside the casing, so that the only moving part actually has no electronics in it, unlike brushed motors which you have in other RC vehicles like RC cars. Now each motor is controlled by a motor controller, which takes battery power and modulates it by pulsing it on and off thousands of times a second to control the speed and direction of the motor. So there's a set number of times that it turns it on and off. However, the ratio of time that it's turned on versus turned off makes a big difference in speed. Each motor controller is fed a signal through these PWM cables to the main board, which in my case is a KK control board. So this board has multiple sensors on it that allow the quad to tell exactly where it is in 3D space. It knows the rate of roll, pitch, and yaw, but it doesn't know where it is in terms of position in X, Y, and Z. It can't tell if it's going sideways or up and down. It only knows the 3 rotational axes of motion. So what it does is these sensors tell it when it's off kilter. So if it's tilted forward for some reason, what it will do is it will slow the speed of the rear 2 motors in order to bring it back to level. If it's tilted in 2 directions, it will lower the speed of multiple motors in order to bring it back to level. So this is cool because that little brain inside this controller does all the work for you. All you have to do is push up on the throttle and it will literally take off and stay afloat for you. So in order to actually move, the control board takes signals from a receiver that's part of a transmitter and receiver pair. So I have a very cheap Hobby King transmitter and receiver pair, which of course does the job. So what the transmitter does is it reads the position of your sticks and transmits them wirelessly to the receiver you have on your multicopter. This receiver gets power from the control board but also sends a signal back through its own PWM cables, 1 per channel. So the controller is busy keeping your quad level, but at the same time it's adding in the control it receives from your controller. So if you push forward, it will lower the speed of the front 2 motors, but still make sure that your quad is level and doesn't rotate. So it can get a lot more advanced than that. There's some controllers that have other sensors such as GPS and can automatically fly to set positions. But this one does those two main tasks and is designed to do it very efficiently. So the other two pieces of hardware I have left on this are the battery monitor and the battery. So let's start with the battery. It's the battery that was included with the kit. I ordered two more like it, but it is a lithium polymer battery that has 1 amp hour worth of power at 11.1 volts. So basically it has multiple small cells. It's made of 3 cells, each with a voltage of 3.7 volts. Now lithium polymer batteries are great because they can output very large amounts of current compared to other batteries, alongside having a lot less weight, a lot less mass than other battery types. So this is great for flying vehicles because low weight and the high current ability allows you to do complex maneuvers and then switch out of them very quickly, which will cause large current spikes. Your motors will draw a lot of power trying to change direction very quickly. On the other hand, these batteries are very dangerous because if the cells drift out of equilibrium, if their voltage is not equal, you can accidentally discharge one much further than the others and cause catastrophic failure. So what's cool about them is each cell is individually wired out to a connector that you can then plug into a battery monitor such as this. So what it does is it actually measures the voltage of each cell and displays it on the screen. And if any cell is below a certain voltage, it will actually sound an alarm. So this is great because you can't always see that screen when you're flying. It's nice to know when you should start slowing down, when you should land. So that is how a multicopter works. I hope that helps those of you who maybe were a little confused or just assumed that it was black magic that kept these things up in the air. Thanks, and see you next time.